All right, my secondary math 1 class. We are going to be reviewing today. That means that next class is going to be your test. Okay, so the review notes are probably the most important. If you've lost all your other notes or thrown all your other notes away, please keep these ones because these will cover everything that is going to be on the test. Okay, so let's remind ourselves. I know we've talked about this before, but whenever it says a system or a systems of equations, it just means more than one equation. Okay, so we're solving systems of equations. Okay, we've learned a couple ways to solve systems of equations. The first one we've learned is by graphing. Okay, so we're going to take both of these equations and we're going to graph them and see where they intersect because that is our answer. Okay, remember the answer or solution to a system of equations is always a coordinate point where x comes before y. Okay, so let's go ahead and start graphing these. So I have my first equation on number 1. Okay, so they are all in slope-intercept form, which tells us we can identify the slope and the y-intercept. So of my pink equation, what is my slope of my pink equation? Okay, remember my slope is always right in front of my x, so my slope is 5/4. And when they're written in fractions, that really helps us because that tells us rise over run. Okay, well, what is my y-intercept? My y-intercept is the number without an x, so that's going to be a +1. Okay, now let's go ahead and graph our second line. Okay, so my green line, now I have my slope and my y-intercept of my green line. And actually, before we identify those, let's go ahead and graph our pink line. Forgot to graph it. Actually, put it on the graph. Okay, so what is our starting point? Do we start with our slope or our y-intercept? Remember, we always start with our slope. We always start with our y-intercept. I don't know why I just said that. Okay, your y-intercept is always your starting point. So find +1 on your y-axis. It's going to be right there. Okay, so now that we've put our first point, we can use our slope, 5/4, to count to our next point. So we're going to go up 5, 1, 2, 3, 4. We don't have room to go up 5. Okay, that's okay. We can always go backwards. Let's go down 5. 1, 2, 3, 4, 5, and back 4. 1, 2, 3, 4. Okay, remember, I had to go back 4 because a positive slope always has to go up and to the right. Just like that. Okay, so now that our pink line is graphed, let's go ahead and graph our green one. So what is my slope of my green equation? It's going to be 1/4. Okay, then what is my y-intercept? -3. Okay, so our starting point is always our y-intercept, so find -3 on your y-axis. It's going to be right there. Okay, and now I'm going to go up 1 and over 4. So from this point, up 1, over 1, 2, 3, 4. Okay, I still don't see where they intersect yet, so let's go backwards. From our starting point, let's go down 1, 1, and 1, 2, 3, 4. Okay, now I see where these two lines intersect, because that is what our answer is. Okay, so what is this coordinate point right here? Okay, line it up with your x-axis first. It lines up with a -4. And then it goes down to -4. Okay, so our answer is -4, comma, -4. And that is our answer. Okay, so now let's go ahead and look at number 2. So we're going to do the same thing. So let's look at our first line. So identify our slope and our y-intercept. Okay, what is my slope of my pink line? It's going to be 1/3. Okay, my y-intercept is +4. Okay, so we're going to start with +4. So find +4 on your y-axis. It's right there at our first point. Okay, and then we're going to use our rise over run with our slope. So rise 1 and run 3. 1, 2, 3. Remember, we can always go backwards. Go down 1 and back 3. Still creating that same straight line. And there we go. Okay, so now let's go ahead and graph our green line. So I need my slope and my y-intercept for my green line. Okay, what is my slope? What's right in front of my x? -4/3. Okay, and what is my y-intercept? -1. Okay, always start with your y-intercept. So find -1 on your y-axis. There we go. And now our slope is -4/3, so we're going to go down 4, 1, 2, 3, 4, and over 3, excuse me, 1, 2, 3. Because remember, this line is negative. It has to go down to the right. Okay, well, we still don't see where they intersect, so let's go backwards. Let's go up 4, 1, 2, 3, 4, and back 3, 1, 2, 3. And there we go. There is our negative slope. Our line is going down and to the right, and we found the coordinate point where they intersect. Okay, so let's identify this coordinate point. It lines up with -3 on our x-axis. Remember, x always comes first, and goes up to +3 on our y-axis. So our answer is parentheses -3, comma 3. Beautiful. Okay, so that was our first method of solving systems of equations, by graphing. Okay, graphing these two lines and finding where they intersect. Okay, so let's talk about our second way that we learned. Okay, so we talked about solving systems by substitution. Okay, and think of when I have a substitute, somebody is replacing me. So when solving by substitution, we're thinking we're replacing something. Okay, so let's look at number 3. So I see on number 3 that y equals this first one. Okay, but on the second one, y also equals that one. Okay, well, true statement, does y equal y? Is y the same thing as y? Yes, that means we can set the top one equal to the bottom one. So I have -4x plus 2 equals -6x plus 2. Okay? So now there are no more y's. Now I can just solve for x. We're trying to figure out what x represents. So notice I have x's on both sides of my equal sign. So I need to move the smaller one. But which one's smaller? -4 or -6? Okay, -6 is actually smaller. So how do I move, or what is the opposite of -6x? It's going to be +6x. Okay, so we can only combine it with x's. So what is -4 plus 6? -4 plus 6 is going to give me +2x, plus 2 was already over there, and +2 is left on that side. Okay, now we can go ahead and solve for x. Okay, so the first thing I need to get rid of is +2, because remember, +2 is farthest from my x. So what is the opposite of +2? Subtract 2. So we get 2x equals, what is 2 minus 2? 0. Okay, and one last step to get x by itself. What is the opposite of times by 2? Divide by 2. Okay, well, 0 divided by 2, we know that x equals 0. Okay, so remember, our answer is still going to be a coordinate point, so we just found the x part of it. Okay, so for number 3 in our answer, the x part was 0, but we still need to find the y part. Okay, well, now what do we do with this x? Remember, we're going to replace it. Okay, so I'm going to take this x that I know is 0, and I'm going to plug it in where I see that x. Remember, you can do the top or the bottom one. I'm just going to do the bottom one. Okay, so I have y equals, right, I'm writing this out. Instead of the x, I'm going to put a 0. -6 times 0 plus 2. Okay, so let's go ahead and solve this. Okay, what is -6 times 0? Anything times 0 is going to give me 0. Okay, and what is 0 plus 2? What am I going to get for my y? Y equals 2. Okay, so we found that the y part of our answer is 2. Okay, so our final answer is parentheses 0, comma 2. And there's our final answer. Okay, so let's do number 4. Let's do this again. So I see on number 4 that y equals this one, but y also equals that one. And since y is the same thing as y, we can go ahead and set the top one equal to the bottom one. So 2x minus 2 equals negative 6x minus 18. Okay, so now I'm only dealing with x's. I don't see any y's in this equation. So I can go ahead and solve for x, but I have x's on both sides of my equal sign. Okay, I need to move the smaller one. Which one is smaller, 2 or negative 6? Okay, remember negative 6 is actually smaller than positive 2. So how do I move it? What's the opposite of negative 6x? Positive 6x. And that's going to move it to that side. Okay, so now I have 2x plus 6x. It's going to give me 8x minus 2 was already over there equals negative 18 left over on that side. Okay. So now I can go ahead and start solving for x. The first thing I need to get rid of is the farthest thing from my x, which is negative 2. Okay, what is the opposite of negative 2? We're going to add 2. Okay, so I have 8 times x equals negative 18 plus 2. We're getting less negative here. We're moving towards a positive. We're going to end at negative 16. Okay, my very last step for getting x by itself. What is the opposite of times by x? Divide by x. Okay, so we're going, or divide by 8, excuse me. Okay, so we're going to take negative 16. You can do this in a calculator. Negative 16 divided by 8, and that's going to give me negative 2. Okay, so we found that in our answer, our coordinate point, okay, remember our answer is always a coordinate point, we found that the x part of it that comes first was negative 2. X equals negative 2. Okay, so now we're going to take this negative 2 and we're going to plug it in. This time I want to do it to the top. It doesn't matter which one you choose to replace it. Okay, so I'm going to take this whole equation. So now y equals 2. That was already there. And instead of the x, it's now being multiplied to negative 2 minus 2. Now we can go ahead and solve. What is 2 times negative 2? It's going to give me negative 4. What is negative 4 minus 2 more? It's going to give me negative 6. So my y part was negative 6. Okay, awesome. So that is solving systems by substitution. Notice we don't have any graphs. We're using algebra to solve here, but our answers still look the same, right? Parentheses x comma y, parentheses x comma y. Okay, well now what I want us to do with this word problem is I just want us to identify how we can build a system of equations using a word problem. Okay, so let's go ahead and read it. So I'm going to get out some highlighters because we'll probably have a system, which means more than one, right? Okay. The school that Kristen goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $50. Okay, so we have 2 days. The first day I'm going to highlight in blue. And the second day I'm going to highlight in yellow. Okay, so this is where our 2 equations are coming from, our blue equation and our yellow equation. Okay, so on the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket. So 2 types of tickets. So I'm going to label senior citizen tickets as X and the child ticket as Y. Okay, so on the first day, they sold 3 senior citizen, so 3x, plus 1 child ticket, 1y, for a total always means equal, of $50. And there is our first equation, okay? So that was our blue equation on the first day. Okay, so now let's look at our second day. The school took in $120, which means it had a total of $120 for the second day by selling 3 senior citizen tickets. Remember, senior citizens are X, and 6 child tickets. Child tickets are Y. Okay, so let's go ahead and label this. So again, I had 3 senior citizens, so 3x, plus 6 child tickets, so 6y. Okay, then it asks us what is the price each of one senior citizen ticket and 1 child ticket. Okay, so we're not actually going to solve that one today. I just wanted us to build these systems of equations. Okay, so you can see where we can grab information from a real life story problem to build a system of equations and eventually solve that. Okay, those are your notes for today. There is an assignment that goes with it.